Hi, and welcome back to Engineering 255 Statics. This is the second video of the Chapter 6. In the Chapter 6, we are discussing about the structural analysis, and we put the emphasis on the trust. In the previous video, we talked about a method called the method of joint, which means when you analyze the force, you look at the joint point of several different members. That is a easy method if you only focus on a point and you simply just use summation force equal to 0, you can analyze to get a solution. In this video, we're going to talk about a second method called the method of the section. Well, the method of the section has some benefit, which is that if you only wanted to know specific member and you wanted to know the internal load in that member, method of the section is easier to analyze. So let's take a look of what this chapter or this section is about. So again, the objective for today's is going to be the method of the section. So we have a truss like this. If we only look at the two dimension, and this will be the truss and as shown in the three-dimensional bridge. If you only wanted to know the section at here, you wanted to know how much of the load that applied to this particular section or the one above or the one below, you can use the method of the section, which will be a lot easier. Because if you don't, you use the method of the joint, you have to either start from this point or this point, and you're going to move to adjacent point until you find this one here. So it takes a lot of steps. So the application of this method is that if you have a long truss and there's several different members, if you go joint to joint, it just takes too long. The method of the joint will take a lot of joint to analyze before you make the final decision of the force in the middle or the large truss. So what is the idea and how do we actually use the method of the section to find a solution? Here you can see an example that we have a big truss like this and there are several members here. When you do a method of the section, you are imagine that you cut the truss into two parts. So in this example, let's just say if we cut it from A to A, and we kind of cut through the BC member, the GC member, and the GF member. And we wanted to know what is the internal force on each one of these cutted members. In the previous video, we also said this is what we call the two-force member. And the two-force member, the force has to go along with the member itself. The force are applied at the two end point. Force has to go along the structure. So when you cut it through, you can imagine that the force along this member are either compression or tension. And we can analyze it in a simple way. So the way to analyze is that you analyze two parts. And you can see in this example, when we cut from A to A, on the left-hand side is this structure right here. This is the endpoint supporting force. Well, this is actually not a supporting force. This is an external force that you have 1,000 Newton pulling down. When you cut this one here, you can assume there's going to be internal force along the member. So there are three forces because you cut through three members. So these are the three forces that you cut through. Now the direction of each one of the force can be arbitrary because your answer will justify your assumption of the direction. It's important to understand the angle between each one of the forces because this is needed when you wanted to analyze the direction of the x and y component. So we need these information to solve. At the same time, if you look at the right hand side of this whole piece, you can see this is the right hand side. If you make assumption this force, the BC force goes to right from the B, then your BC force on the left-hand side should go the other way so they can cancel out, because internally there's no force. You have a force was because you cut it, just like you are doing a free body diagram. When you cut through some of the environment, you have to put a reaction force back into it. So you can use either side to find the solution if, let's say, the FBC is the one that you are interested in. And you can either use right hand side, you can use the left hand side to find that solution. It only depends on which way is the easier to do. So when you have this kind of problem, you need to draw a free body diagram, and you select which part, and then you cut it, and you wanted to, it's easier for you to find a solution. In this case that we have, let's say we wanted to find the member force on the three different members, then you have three unknowns. If you have three unknowns and this is a two-dimensional question, you have three equations, you can solve this problem without any further calculation. So it should be very simple to do it. So when you do it, you use the equation of equilibrium. What are the equation of equilibrium? We have summation F equal to 0. We have summation moment equal to 0. So you just use F of X equal to 0, summation F of Y equal to 0, and certainly you have to decompose the components. So in this one, for example, this is the X direction, this is the X direction. This one you have to decompose it into two different components such that you can use summation Fx equal to 0 to find that. You have third equation, that is the summation moment that equal to 0, and this one, which reference point is going to be important. If I am going to do this problem, I will either choose this point or this point. Well, you cannot choose this point because you cut through this one. So I will choose the point of C because this will save us time to do the calculation, because FBC, FGC, they all go through this point of C, which means these two forces are not going to create any of the moments. So all I need to do the moment calculation is going to be the force GF and the 1,000 Newton force that will create the moment. So you have three equations, you have three unknowns, and then you can solve the problem directly. So let's look at one example and to refresh what we just talked about and to see a complete solution for this example. This is a very complicated truss. You have several different members. There are more than 10 members in this truss. When we analyze the truss, the first thing we do is to draw the free body diagram of the overall structure. So you do a structure from A, L, and goes to the H, and go to the G, and you come back to the A. And then you need to identify what are the reaction forces for each one of the support. For this A here is a pin, so we have these two forces. For the supporting at the G, this is the roller, so you only have one supporting force goes up. You have some external force. These three are the external force, and they give you the dimension for each one of the member. Then you're ready to solve the problem. Now, the problem asks you to find a force in the member KJ, KD, and CD. So KJ is right here, KD is the one at here, and CD is the one at here. Since it wants you to find the external internal force in the three different members, you will cut these three things so you can use the method of dissection to find a solution. Because if we cut through this, you look at the left hand side and you have a force which is go this way. Again, the direction is arbitrary. This will be the force go this way. You can say this force will go this way. And these are the three forces you try to solve. right? So that is the simplest way. Now, why do we need to find a supporting force here? Well, because when you analyze this piece here, this supporting force are the external force acting on this friend if you only isolate the friend itself. So how do we find this reaction force? When you find a reaction force, you don't care about the internal force, which you don't need to consider about these, because you treat this whole thing as one piece. So this is the whole thing that you are thinking about. Okay, this is the whole thing that you're thinking about. So you don't really care about internally what happened. And when you think about the whole structure, you have reaction force right here, reaction force right here, and you have external load right here. And you use summation f of x, which there's no summation f. Well, yeah, so that means ax equal to 0. And you do summation f of y, and you have ay and gy that will be equal to the sum of 20k, 30k, and 40k. And that is how you find the summation f of y. The last one you would do is to do a summation moment. I probably would choose point A. You can choose point G. I think it doesn't matter because ax equal to 0. You only have one supporting force at A and one supporting force at G. So either one that you choose will give you the solution. So here we just show you how we find a reaction force. The reaction force is about the A and G, right? Summation f of x give us ax equal to 0. And we use the moment equation about the point of G, which is right here. That means the reaction force at the G is not going to give you any of the moment. And you have this force create a moment, this force create a moment, this force create a moment, and the force that is AY will create a moment as well. AX equal to 0, so we don't consider about that. And this is the summation moment of G that give you the solution of AY is 56.7 K Newton. Once you find the reaction force at that point, you can start to use the method of the section. So you cut this member right here, and if you look at the left-hand side, and we can simplify the left-hand side free body diagram. This is the free body diagram of the left-hand side of this part here. The reaction force is something that we saw in the previous step, and we have external force 20 and 30. We don't include 40 because 40 is on the other side, so you only include the 20 and 30. You cut through each one of the member, the force will go along the direction of the member, so you got these three different forces. And then if you look at this problem here, you have three unknown. You have three equations that you can use, and you can solve this one. So how do we solve this? You take summation f of x equal to 0, summation f of y equal to 0, and you take the summation moment that equal to 0. You can pick any of the point. I probably will choose this point here, which will be the point of D, and that is the place where you have two different force intersect at the same point. Now that you look at this problem, you do the similar thing. You do summation of x equal to 0, summation of y equal to 0, and then you can find the FKD and FCD. Just by doing that, you find those two solutions instantly. Then the other force, if you want to find that, which is the what? We have KD and FCD, so these two are solved. And we want to solve this one here. Now you can actually just use a simple point at the K to find a solution, because you already know FKD, how much the FKD is. You can decompose that into the X and Y, where the X should be canceled out with this one here. So you can find a FKJ by making the FKD times cosine of this angle, and that should be equal to FKJ, and then you can find a solution. All right, so in this video, we talk about the method of the section. So it's very important that when you do the method of the section, the first thing you do is actually draw the free body diagram of the whole truss and solve this supporting force. And the third step is to cut the section, cut the truss through the members that you are interested. When we say interested, meaning that you wanted to know the internal force of that member. And then the number 4 is select either side of the cutted structure and use the equations of equilibrium to find internal load. So that is the summary of this video. We'll see you in the next video.